comes to ICP. So for this session, feel free to ask pretty much any questions that you have about ICP, particularly development, and happy to answer as best as I can. Is there a text chat that I should be able to see, or people can ask questions out loud?
Yes, Kai, hi. My name is Steve. I'm the current project manager and developer relations at ICP Hub Kenya. I thank you that you actually took the opportunity and started off the session, and also thank you for introducing yourself. But before we start officially, I don't know whether Tevin is in the call. I wanted Tevin to just give a small intro. Then, since you've already introduced yourself, we can just head over to the Ask Me Anything questions. The questions for the Ask Me Anything session. But I can't see Tevin in the call. But I think I'll just kickstart it. So as you guys know, today it's our special. It's a special session, since we're having one of the core software developers from Dfinity with us. I hope you guys have prepared your questions, and I think without any further waste of time, we'll just head over straight into it. So if you have any questions, you can feel free to mute yourself, or if you're too shy to talk, you can just type in the Telegram group, just under in the Telegram group. You can just send in your questions over there. So Kai, over to you. I think we can just proceed from there.
Sounds good.
So I see maybe people are still brainstorming the questions they have. So I'll just break the ice. So I think my question for you is as you've worked in Dfinity over the last the time period that you've worked in it, can you give us some of the key challenges that you've faced in implementing some of the features or updates in terms of now internet computer protocol?
Yeah, absolutely. So if we wind back time to when we first launched, at that stage, we were still finalizing a lot of things. We hadn't really implemented cycles management yet, so the ability to pay for canisters. Identities and wallets were still very much an open question. And even things like integrating with centralized exchanges with the Rosetta API were still somewhat of last-minute features that we added. So the burst of development of getting ready for launch was really, really active. But there have been a lot of interesting features since then. So one of the first things I worked on actually was Internet Identity, which is the authentication provider that we have, that Dfinity puts out. Allows you to use web authentication to log into different apps, getting your principal back, and all of that great stuff. That very much is a tricky question, right? Because whenever you're building something that is going to hold value for people, retrieving access to people lose devices all the time, people don't necessarily back up things. And when we first launched, one of the early bugs that we encountered was if you clear your cache on Safari, it would wipe your crypto keys and you could lose access to being able to log in again. So we had to do quite a bit of trial and error. We introduced the recovery phrase, encouraged people to add multiple devices. and I've kept going from there. I think one of the really interesting problems that we've been solving lately has to do with integrating with other chains. So the threshold ECDSA signatures, which are what we use to hold Bitcoin addresses, Ethereum addresses, and also just for canisters to be able to make signatures on the payload that they respond with. It's a very powerful feature and um, very difficult and a novel solution that our researchers came up with in order to make it happen. Um, but that is one unique feature of the Internet computer where a smart contract can itself create signatures and hold tokens while none of the actual nodes have the secret key. Very, very powerful tool and an exciting thing that developed in the last couple of years.
Okay, awesome, awesome. Yeah, thank you for that. I think it's we can clearly see that you've actually done some amazing work, especially with one of the most commonly used features for the authentication, that is the internet identity. So I see. Okay, yeah. I don't know whether anyone has a question, or you guys are sending in your questions to the. I can see we still don't have any questions. So do we have any questions from the people that are listening in? I can just throw another question. Yes, I think we have a question.
I'm planning to join open summer camp by
Um,
September. So, hello.
Joe, I think Joe, you're talking, but we can't hear
Yeah.
you.
Okay. Hello. I'm Joseph Njoroge. I'm a full stack developer, and you mentioned about your the various bugs that you've been facing, which gave me this question, and I would kindly like to ask, can you share a significant failure or a setback in your career, and how and what did you learn from it?
I think the biggest setback I had was relatively early on. It has nothing to do with crypto, but I took after my first full-time job as an engineer, I had the opportunity to get a more highly paying position that was a contract role through an agency for a company called Splunk. And the day before I was due to start, I got a call from my recruiter. I'd already signed all the paperwork. I'd quit my job. And I got a call from the recruiter saying, there's a problem. They're not going to be ready for you to start tomorrow. And it turned out that the hiring manager who had hired me quit and left under like really bad terms. And suddenly the sort of executive who was above him was not at all happy with any of the hiring decisions he made. And so I just didn't have a job. And yeah, it took me about a month and I wasn't able to find a new position. I was still very early in my career. And eventually I convinced them to let me re-interview with the same team and the same people. And then they gave me the position. I only stuck around there for like 3 months. They still were not happy to have me. And yeah, it taught me a lot about the safety or the thoughts that you think you have about what is a safe career move and how much risk there really is. And it really taught me to be more canny or to be a little more thoughtful about an interview isn't just this opportunity exists and like this money exists on paper. You also have to think about who you are going to work with and that the interview process is a two-way street. You're interviewing the company that wants to hire you as much as they are interviewing you as a worker. Yeah, so it taught me to be a little more, to have more discretion when talking to future employers.
Joe, does that answer your question?
Yeah, very much so. Thank you very much for that answer. And I also have another question. How do you envision the internet computer shaping the future digital landscape for the next generation? Because right now, what we are focusing on is shaping the new generation that's to come. So, how do you envision the internet computer into shaping the future digital landscape?
Yeah, absolutely. When I think about how the internet computer could shape the future digital landscape, I think one of the most interesting properties of internet computer smart contracts is that you can create a new smart contract or an application without entering into some sort of business ongoing relationship with some hosting company, right? Even the companies that have like a free tier, like hosting a website on Netlify, um, there is a lot of process that it takes to get set up with that. And the ability for the internet computer to spin up a new website or a new application for any particular individual user who's out there, where they can have actual control over something. So if I'm an app developer and I can say, here is this new application I've created for you, I paid for it, so you don't even have to worry about funding it, but now it just exists and can continue running, and it is fully yours. That's a really radical way of doing computation. So that is an area that I'm always interested in seeing how people experiment with, such as OpenChat is one example of this, where they'll create new canisters for the group chats. I think it's also got a lot of potential for, if you think about things that a company has decided to deprecate or stop supporting just because it's no longer profitable. So, for example, video game developers will stop running servers, or Nintendo shut down the 3DS shop so that no one can sell their games for 3DS anymore because they just didn't want to bother running those servers. Once you've got the internet computer as a model, anyone who finds something valuable can keep it running by continuing to pay for it. Maybe development may stop, but the actual application can keep running as long as anyone finds it worth keeping it alive. So I think that has the ability to change the game in some real ways.
Thank you very much.
Okay, awesome. I think we have like two questions in the TG group. So the first one is, I'll just quote it. As a software engineer at Dfinity, how do you view the evolution of blockchain technology from the perspective of developing decentralized applications? And what do you think are the biggest challenges facing this development, and how does Dfinity play a role in overcoming them?
Yeah. So some inside perspective I have is, from the get-go, since the internet computer launched, we've had two types of ways to interact with a smart contract, or I guess three. We've had queries, updates, and an HTTP interface. Queries have begun an evolution because we started attaching signatures from the individual node that made the query. And of course, updates go through a full round of consensus and they're more secure. But a query can talk to a single node, so you can only trust as much as you get back, we have this strategy for certifying a query using the state tree, but that's pretty complicated for individual developers. And we found that a lot of people haven't adopted that strategy yet. So we're working on ways to make that simpler. And the next step in that process, the next evolution, is going to be having multiple nodes not go through consensus, but multiple nodes make the same query and then compare the results to make sure that they match. So you'll get something like, instead of a single closest node, we'll get 3 nodes for pretty equivalent performance. But that allows the HTTP gateway or your browser or your application to do verification and say, okay, yes, these nodes are not being malicious and their answers match. So that's one really exciting direction. And also the HTTP interface has evolved a lot as well. We have the ability for applications to sign and attach a certificate header to any HTTP response, allowing you to do it as a query. And we have a couple strategies now for Rust and Motoko. For example, I wrote this app or this library called Server in Motoko, which allows you to run an Express.js style HTTP server and both accept like post requests for data that comes in and respond with HTTP responses, which opens up a lot of flexibility for a canister to behave more like a traditional server. Now, of course, that isn't a perfect solution. Even with like HTTP outcalls, the fact of replication is a big challenge. There's increased latency. There's the inability to kind of just do things as dynamically as we would like to. When you're used to traditional servers, that is. And be able to do things like make an HTTP out call in the middle and or talk to a database or something behind the scenes. That's a big challenge, and so is secrets. Anything that needs to be usable by the canister itself, so code needs to access it, but you also don't want the node owner, the person who physically controls the replica that's running. If you don't want them to be able to see the secrets that you've stored, like your API keys or potentially things like usernames and passwords and all of that, to keep that secure, we have to do things like encryption, and that makes a lot of traditional Web 2 flows very difficult. For example, most authentication is done using bearer tokens and cookies and all of that sort of thing. And that becomes a very difficult challenge when you essentially, by the nature of what the internet computer is, have a sort of person in the middle attack that's always, it's a guarantee. There is someone who controls parts of the infrastructure that you don't trust. So you have to rely on signatures in a way that a lot of the old Web 2 stack just doesn't do. So when you're trying to integrate, there are new trust assumptions that we don't have in the internet computer or blockchain ecosystem. So making those two fit together becomes a little more challenging.
Okay, yeah. Thank you. That was quite elaborate answer. So I see we also have a number of questions in the Telegram group. So I'll just head over to the second one. So as an experienced software engineer, what do you think are the latest trends and developments in the blockchain ecosystem and decentralized application development? And how do you see Dfinity's role in driving innovation and adoption of blockchain technology? And what do you see as key opportunities and future challenges for application development on ICP? I hope it wasn't too long.
Yeah, I'll try to answer a little bit quicker, just so that we can get through some more questions. The big trends I'm seeing right now are people are obviously very interested in AI. And there's some renewed interest in like meme coins, I guess. And also zero knowledge proofs are a topic that people are pretty interested in. So yeah, people are broadly very interested in scaling the performance of various chains, things like Ethereum and other L1s have scaling problems. They can only handle so much throughput before gas fees and latency become a really big problem. So the internet computer can really help with, for example, like chain key ledgers, and that's probably the one of the more interesting things that we have to offer right now. But I think that there's also the fact that internet computer is a compute layer in a way that pretty much nothing else in crypto is. Um, gives you the opportunity to run software, host your website, and if you're committed to doing things in a Web3 way, the internet computer is a really great tool in that toolkit.
Okay, awesome. Yeah, so the next question is in the context of adapt development, what do you think is the important role of the concept of decentralization, of decentralized digital identity and blockchain-based access rights management? And how do you see the future of developing applications that leverage decentralized digital identities, and what does the industry need to do in order to ensure a wider adoption of this particular concept?
Yeah, I mean, to back up a bit, it is absolutely possible to build things with a username and password system on the internet computer, but we don't recommend it. Decentralized digital identity, there are a lot of different standards for this, right? I haven't really seen a lot of interest in working with specifically the DID spec, DID, decentralized identifiers. We've used principal identifiers, which is basically just a way of representing your public key. But how you retrieve an identifier is a really important question. So people have built things like sign in with Ethereum integrations for internet computer, obviously internet identity, NFID, and some other strategies, as well as people who just use sort of classic wallets. But adoption's a really big problem, right? It's hard to convince someone to download some new piece of software or make an account somewhere. And so I think the biggest challenge that we have is going to be making things as seamless as we possibly can. I think that passkeys, because of how hard Google and Apple have been working on increasing the availability of those, is going to be a really important tool. But yeah, we've still got, I think, a way to go in terms of the developer experience of don't make developers manage too many things, like going all the way down to the level of integrating with passkeys, but can we create some tools that make the onboarding as painless as possible, and as good of an experience as we can?
Nice. Yeah, that's a really good response to that particular question. Yeah, because I think if we actually lower the barrier of entry in terms of the kind of work that or the kind of heavy lifting that the developers need to make in order to build these particular applications, I think we're going to have like some good adoption. Yeah. So the next question is, what steps does Dfinity take to ensure the integrity and reliability of data stored on ICP, especially in face of potential attacks or network failures?
Yeah, I mean, this is basically what the internet protocol is, right? So Dfinity doesn't have to do anything now that the network is running because of how it's designed. aside from just continuing to like onboard and scale as necessary through proposals. But the short answer of how this works is because the node providers are doxed, we know who they are. We know that the nodes themselves are distributed throughout the world so that they don't have any sort of co-location problems or risk in that way. The Internet computer has this property, which is called Byzantine fault tolerance, which is that beyond a certain threshold, you can have quite a few nodes in a 13 node subnet fail to make a new block or fall behind for whatever reason, whether that's due to traffic or some sort of catastrophe or loss of power. And the network will still be able to continue. So eventually, if a node continues to stay behind or has been fallen off, we can replace that through NNS proposals. But the fortunate thing is that the network will continue to be resilient. 1, 2, 3, 4 nodes could all just go down, and no data would be lost because of the replication.
Okay, awesome. So just in a nutshell, you're saying whenever certain nodes maybe decide to probably shut down or go off because of a few technical glitches, the whole system will still continue running regardless of whether they're on or off.
Mm-hmm. And even if a single subnet has degraded performance, other subnets will continue just fine. But yeah, certain individual nodes fall behind all the time and are able to catch up through the checkpointing routine that they automatically go through.
Awesome. And what about in the face of, let's say, a potential attack? Maybe one of the nodes gets hacked. Are there like risk mitigation strategies for that particular issue?
All the way throughout the stack, we assume that every single node is malicious. So we are designing all of our tooling, all of the way that the agents work, all the way that the HTTP gateways are designed. We don't trust any particular part of the stack. We assume that everything is a malicious actor that is looking to steal everything from you. So everything is redundant. And we're looking at it in the terms of if we assume that a node is behaving maliciously, how do we protect a user from receiving bad information or being tricked into making updates or additional payments, so on and so forth. And that's going to be a series of making signatures, checking signatures, enforcing that certain requests, like anything that goes through HTTP, needs to have gone through an update before it's able to have a certificate attached to it. So certified queries is another strategy that we can use. But yeah, like the assumption is that not only is something hacked, something is fully owned and possessed and controlled by an agent that wants to take down the internet computer. And as long as like we don't hit a 2/3 threshold of people coordinating in that way, we're designed to be resilient against that.
Awesome, thank you. That was quite elaborate. So another question. So more on the developer experience side. Just quote in quote, she says that she really likes playing with the HTTP requests and interacting with Web2 applications directly, but then she has faced a little trouble with some of the requests whereby someone can only perform get and post requests. So are there plans to add put anytime soon?
I haven't looked into that recently, so I'll take a note about that and check with the team.
Okay, awesome. Yeah. So also another question: how do ICP canisters achieve interoperability with other blockchains and external systems?
All right, how do we achieve interoperability? So Bitcoin is actually considerably more complicated than Ethereum family chains. But the basic mechanism is we're using chain key technology, the same thing that uses or that allows the canisters to come to consensus among all of their nodes. We keep secrets from the individual canisters, but we're using threshold signatures for making ECDSA signatures because that's what's required to interact with these other chains. And those signatures allow you to have a secret key that is essentially the address for that canister. So once you have the address, the secret key or public-private key pair, you're then able to send tokens that will be controlled by the canister, but no individual node's able to control. So between that and HTTP outcalls, being able to talk to the APIs that make changes, that gives us the ability to receive and hold tokens on another exchange, and then to make the signatures and the requests that will allow you to transfer tokens or just make other interactions. And we're currently working on threshold Schnorr signatures, which is going to have applications for Bitcoin as well. But that's the gist of how it works.
Okay, awesome. Yeah, I think chain key cryptography implemented by you guys it's quite a revolutionary technology when it comes to blockchain. So another question from one of the guys. So in the context of internet computers, how do you see the role of smart contracts and decentralized applications in changing traditional business paradigms? So especially in terms of creating a more inclusive ecosystem and empowering users to actively participate in the networks.
Yeah, this is an interesting question. I've talked to a bunch of businesses more in the traditional enterprise world, and it's a complicated question because the way that people will have the incentive to do things is a really interesting topic, right? Historically, businesses have a lot of incentive to control the data and hold all of the cards close to their chest because they're able to monetize that. And changing the system so that the incentives are such that users have incentives to participate or to own. And we take some of that control a little bit away from the sort of centralized business strategy. It's going to be a dynamic process. I think established players aren't necessarily going to be jumping to do this all of the time. There will be some niche edge cases, particularly around data privacy or potentially things like GDPR and other user control of their own information type of laws, I think will actually be important in encouraging this. But I think that new businesses, and particularly being able to undercut some of the players like credit cards with their transaction fees and being able to scale things up cheaper and to be able to compete with the existing players is probably going to be where I imagine some of this change is going to happen. So, if you've got someone like Lyft coming in or Uber and taking 40% of the pay, or like Google Play or the Apple App Store, someone might be able to find their way in by offering a cheaper alternative and taking less of a cut. that's a way that I could kind of see the internet computer getting a real foothold, but part of it remains to be seen. There's a lot of potential for ways that this could go.
Okay, awesome. Yeah, that's quite an elaborate answer, and I do agree with you. We need to take the power, not literally snatch, but ideally just take the power from the central entities to now the users themselves. So I'll just ask one last question, then you can give your closing remarks, and we can end this particular session. So this question says, what is the process for handling large-scale data sharding within ICP canisters, and how does it impact query and also transactions performance?
Yeah, this is a great question. So for one thing, we've scaled up the size of what an individual canister can store quite considerably. So I think now you have something like four, I hope I'm not wrong about this, but I think it's like at least 40 gigabytes that an individual canister can hold. So by increasing the stable memory of a canister, you can hold quite a bit of information inside of one. Obviously, for something like really large data sets and for like a video storage application, you will start to run out of that. But just in terms of like storing information, a lot of canisters will be able to scale quite effectively in a single canister architecture. There are some strategies that people have come up with, though, for very large data sets. So we have things like CanScale is the go-to application, I'd say, to look into for managing fleets of canisters and automatically scaling arbitrary data. I think Juno has some tooling around this as well. But at a certain point, depending on your preference for how to store data, like if you have like a strong preference for like an SQL type querying strategy or a vector database, we are seeing players come out and basically write their own system. We have a lot of flexibility in how an orchestration can work, but you're very right to point to the fact that latency can increase. The strategy that I would encourage is, to the best of your ability, try to keep your fleet for an application within a same subnet, because that'll allow you to use composite queries, which is a newly released feature. And that'll allow a query to one canister to then query another canister that's within the same subnet, and retrieve the response with more of a typical query type latency. So that would allow you to go to an index canister and then forward on the request. If you do need to scale beyond the bounds of, say, an entire subnet, then what I would encourage is move some of that routing logic into the application itself. So have some knowledge of what lives in which domain, and then reach out to the different canisters directly from the agent so that you can have more of a direct path for the best performance, instead of having canisters call other canisters. Limiting that is important for performance.
Awesome. Nice. Yeah. So I think based on the type of responses that you've given us in all these questions, I think we need to put more work in actually learning the nitty-gritties of how exactly ICP works, and also how we can leverage the different features in order to help us like build more scalable applications or decentralized applications. Yeah, so thank you so much, Kai, and I'd like you to give maybe your closing remarks so that we can now release you. Yeah,
absolutely. Once I'm done, I'll share a couple links. I highly encourage everyone to join the developer Discord and the ICP forums. There are some fantastic engineers that are spending their time for free in there, just helping grow the community, answer questions. So really good places to get plugged in. But what I will say is I'm very happy to be here to speak with you all. I think that the opportunities that exist inside of Africa broadly, but also very specifically in Kenya, are really exciting. I love the energy. I love the youth, the interest in technology to solve problems that are facing your own communities. And I love the lack of cynicism. As someone from the United States, we're in kind of a pretty cynical moment when it comes to crypto. And so I think that it's always refreshing to me to see people who are taking this technology seriously in the ways that it's able to change the world and to have actual effects on your local community. I hope that you all have a fun time building on the internet computer. I hope that this is a wholesome community for you. And it's been an absolute pride of mine to be working on this for the last 3 years. And I hope that all of the work that we put into it makes your onboarding process and your learning journey as smooth as possible. And I can't wait to see what you guys build.
Awesome. Thank you so much, Kai. Yeah, and for sure, we're actually having a good time building on top of ICP. Yeah. Yes, so I think you're free to leave the call, not unless someone may maybe have a burning question, of which I do not think so, because they could have asked. Yeah, I think we've come to the end of the session. Thank you so much, Kai, for the opportunity.
Hello, Steve.
Oh yes, Dedan.
Sorry, I joined late. I was held up somewhere. So I just came with one question. I think this has been burning me ever since. So we are trying to come up with something as ICP Hub Kenya in terms of handling DFX commands, because there are too many. There are too many. So maybe on some guidance that you can offer, we are trying to do abstractions of these commands so that they can be able to be coupled together, so that a developer doesn't need to each and every time go and research when you have to do DFX cycles, when you have to deploy on mainnet, when you have to deploy your single canister. Like all of these commands, we are trying to sort of create shortcuts because, we are lazy developers. So, so maybe on some advice on the best way to approach this situation.
Yeah, it's an interesting problem set when we're designing, and I do work on DFX specifically. We try to make it so that DFX deploy as a single command works out of the box as well as we possibly can, so that there's not as much for you to think about. And the templates that we start with out of DFX new are pretty well designed to work in that way, where you can just say DFX deploy and not really think about anything else. However, as your use cases get more complicated, and people's use cases get very complicated, we have other needs for being able to break up the steps, do things like DFX build, DFX canister create, DFX canister install. It is tricky, and recently we did just add tab completion for DFX. That's a nice little feature. There's a little blurb in the release notes about how to turn that on. And I encourage you to use the help command just as a way to sort of explore it. There's more that we can do here, but my recommendation is take advantage of the design of the DFX new projects. Even if you have something that you've already started working on, see if you can use some of the structure and automation of those templates. because they'll set you up so that you have not as much to worry about in terms of understanding DFX.
Thank you. Just what on top of that, I was wondering whether does DFX work in the same maintenance services like Node, as in terms of LTS mode, because new versions have been coming in really hot. I don't know, I'm using version 0.20. I don't know if that is the latest, but I think there's something else that is new. So in terms of LTS mode, because you find that I might deploy a project using the latest DFX version, but then one of my core contributors is using maybe, let's say, DFX 0.19. So in terms of LTS, does it behave the same as Node? Because still in the same essence, Node, I think Node version 18 is and above, or I think just 18 is being supported for DFX. Maybe you can elaborate on that kindly. Thank you.
Yeah, I just had problems where Node 16 being unsupported on GitHub just caused some of our CI to break. So I understand the pain there. As far as DFX, we don't have an official LTS sort of offering. What I will say is I know people are still out there using DFX 0.15, and we have designed the APIs of the Internet Computer in such a way that they are backwards compatible, both in terms of the public API and of things like the management canister. So generally speaking, if you're on an old version of DFX, you are going to have an old version of the replica running on your machine, and you're going to have outdated, for example, Cycles wallet or asset canister hashes that will just sort of be existing for a ways back. So updating gives you access to new features, and we've tried to make that as painless as we can, particularly with the DFX VM. But yeah, old versions will continue to work pretty much indefinitely to the best of our ability. And on top of that, in some new versions, one of the things that we're working on is decoupling replica versions, asset canister hashes, and a bunch of other things from the individually shipped version of DFX, so that you'll be able to update those pieces independently. And that'll allow for some very long-term old support of DFX versions where you can continue to update bits and pieces without updating the actual version itself all the time.
Thank you, Kai.
Thank you, Dedan. Yeah, I think we can now wrap up the session. Thank you so much, Kai, for making time and giving us those insightful responses to the questions that we had. And yes, I think we've come to the end of our call.
Great.
Yes.
Have a great evening, everyone.
Awesome. Also have a great time. Yeah, thank you so much.